Are you ready to dive into the fascinating world of generative agents and their potential applications? Today, we're going to discuss an intriguing article authored by students from the prestigious Stanford University, published in April 2023. This scientific paper introduces generative agents, which are agents that simulate believable human behavior. These agents use generative models to create daily plans, react and replan when necessary, and interact with their environment. They are capable of drawing inferences about themselves, other agents, and their environment, and can respond to changes or natural language commands from users. The architecture for generative agents consists of three main components: memory stream, reflection, and planning. The memory stream records the agent's experiences in natural language, while the retrieval model surfaces relevant records to inform the agent's behavior. Reflection synthesizes memories into higher-level inferences, allowing the agent to draw conclusions about itself and others. Planning translates these conclusions into action plans and detailed behaviors for interaction and reaction. Using the GPT large language model, the authors demonstrate a society of 25 agents in a game environment where users can observe and interact with them. The authors provide two evaluations of their architecture: a controlled evaluation and an end-to-end evaluation. These evaluations establish the importance of the architecture's components and identify potential breakdowns due to improper memory retrieval. The paper also discusses the opportunities and ethical and societal risks of generative agents in interactive systems. It argues that these agents should be tuned to mitigate the risk of users forming parasocial relationships, logged to mitigate risks stemming from deepfakes and tailored persuasion, and applied in ways that complement rather than replace human stakeholders in design processes. The paper demonstrates the behavior of generative agents through a detailed example featuring a small society of agents interacting with each other and their environment in a game setting, showcasing the potential of this technology in creating dynamic, interactive, and believable virtual characters. Let me share my thoughts about inevitable things that this research may bring. The potential applications of generative agents are vast, covering multiple domains such as roleplay, social prototyping, virtual worlds, and games. For instance, users can safely rehearse difficult conversations or prototype complex interactions that unfold over time. In games, the agents can create dynamic and interactive societies that respond to user inputs in a more natural and engaging manner. The future implications of this technology are significant: enhanced realism in virtual worlds and games. Generative agents can create more immersive experiences by simulating realistic human behavior and social dynamics. Improved training and simulation tools. Users can practice various social scenarios, such as job interviews or conflict resolution, with agents that behave more like real humans, potentially leading to better real-world outcomes. Ethical and societal considerations. The development of generative agents must be approached with care, mitigating risks such as users forming parasocial relationships or the potential misuse of technology for deepfakes and tailored persuasion. It is also essential to ensure that generative agents complement, rather than replace, human stakeholders in design processes. In conclusion, generative agents hold great promise for revolutionizing interactive systems, virtual worlds, and games. However, it is crucial to develop this technology responsibly, considering ethical and societal implications while maximizing its positive impact on user experiences.